Okay.
That sounds fine. Here comes my sharing screen. Desktop 1. What the heck is that? All right. Get this out of the way. Okay. I think I'm ready to go. Okay, so I'm ready to go. Is that okay? I think we'll start. So
Yep.
welcome to our weekly weather discussion. Got some interesting things to talk about this week. It's been quite a week. And I think I'll start just by showing the satellite movie. Pete and Tom Whitaker have put their heads together to create this really great 1 week animation. So this goes from last week, Friday at the Weather Watch time to right about now. And there's all manner of ways to control it. And even for an idiot like myself, it's not impossible to do that. Somehow I just made a mistake. But it's got all the instructions on top. Pete sends emails about it as well. But I'm going to just show the whole week because there's enough to talk about. And it'll just be a few seconds anyway. So here's our week. That's the first day. We had our storm go through last Friday and Saturday. I think we had a little bit of snow, and then it got cold afterwards. Friday was the last day with a high temperature above 11 degrees that we've had. It was 15, and that was probably at midnight Friday into or Thursday into Friday because we had the snow on Thursday. So it was a chilly week, and you can see when you're thinking about this as an infrared image, which it is, this is just kind of the lightest gray scale that we have, and that's just because the air is so darn cold. It's really not cloudy here. It's cloudy on the periphery, but it's not cloudy there. And that's just cold advection, just funneling in over the whole weekend. We had some really cold weather, as you know, temperatures in the mid-teens below zero in the week. What you'll see here is storm number 1 developing over the east coast of North America and then heading towards the Greenland Sea. And I'm getting myself obscured a little bit by these images, but you can see there's one big storm rotating in the Greenland Sea. Here comes yet another development late in the week that's going to develop off the east coast. It's just about now coming in. And that's going to take the place of this storm, which I'll show you some satellite imagery from that. That gets sort of eaten away by the end of the week. So you'll see storm number 1 is right, where is it? It's not quite this one. It's this next development that was a sort of another blow of snow to the northeast part of the United States. That's heading up into the Greenland Sea. Very beautiful disturbance, well wrapped up, got into the 960 range or something like that. So category 3 hurricane. And then here comes the next one that's going to develop late in the week. It's actually developing yesterday into today. Here it comes right here. And it's going to take shape and fill in that space in the Greenland Sea. And I'll show you another view of that in just a minute. So that's some of the interesting weather from this week. And it turns out that establishes a really strong positive NAO, of course, because there'll be a sort of a permanent cyclone sitting there in the southern part of the Greenland Sea. And that's part of the couplet of strong Azores high, strong Icelandic low that puts the NAO into a strong positive phase. And that tends to mean warmer temperatures over the eastern part of the United States as that wears on. So we'll see whether or not we're going to really be the beneficiaries of that as the coming week rolls forward. I want to just point out again the whiteness or the light grayness over the central provinces of Canada. You'll see this reflected in a number of other analyses that I'll show. This is simply testifying to how cold the air is. This is being an infrared image. So these clear air temperatures are on the order of some of the temperatures of the higher clouds over Wisconsin. So it's just bitterly cold. And that sometimes shows up vividly as it does this week on the infrared satellite movie. So it's quite a dramatic look at this thing. So I think what I want to do before I go to the continental US is get this other view of that storm in the North Atlantic. So that's where we'll go next. I've got that set up here this is Environment Canada, and I'm showing you a 2-day animation. Yeah, this starts on the 10th, and I think it's every half hour. So it's a lot of images, but watch this. Let's see, I'll get it going and then I'll slide back down. So that's a huge storm. Look at how much of the North Atlantic it occupies. And that's storm number 1 that's sitting there in the North Atlantic. And you'll see coming in off of continental North America, here comes the development for storm number 2. And as it really starts to get itself put together, you'll see especially a little curlicue back on the western side of this thing in a minute. You're going to see how this storm number 1 really devolves into a bunch of smaller scale little swirlies. There's one there, and so on. But here comes storm number 2, a whole bunch of little swirlies in the Greenland Sea, as you can see. And then here comes storm number 2. This one is a beautiful event. It also gets down into the sort of high 950s or low 950s. 952 millibars, I think, is its minimum sea level pressure. Meanwhile, a really weak Azores high is sort of sitting off the northwest coast of Africa. And so the strong NAO that I presume is occurring right now, and you'll see it evidenced in the zonal jet as well across the Atlantic, is largely a function of the successive cyclonic events that have invaded the Greenland Sea. This is really impressive storm. Look at that thing. Isn't that amazing? And as I say, it gets down to about 950 clouds going on over the British Isles. So let me show you an image from, this is 12Z this morning. No, I'm sorry, I'm going to step you through Alicia Bentley's maps. These start at 12Z on the 10th, so it's going to mimic the satellite movie we just saw from Canada, Environment Canada. So here's the first storm. This is the 984 millibar isobar. So that's 980, 70, 72. So it's down below 970 at 12Z on the 10th of February, which was just a couple of days ago, Wednesday. And we'll step forward. How am I going to do that? Oh, come on. It doesn't matter how much preparation you do, you still get this kind of thing. Okay, so let's see if I can step. Here we go, stepping forward. These are every 12 hours. I get every 6. So this is 12Z on the 10th. And here comes storm number 2, just at the kind of nose of this zonally oriented jet across the central and then eastern United States, and watch how that continues to develop. As storm number 1 falls apart, here comes storm number 2 to fill in the gap. So there's a persistent region of really low pressure sitting over this. Now we're too far ahead. This is 18Z about now. A persistent low pressure, 968, 64, 60, 56. So this thing is down below 955 millibars. And that's not even at its most intense. It was more intense earlier. We'll see from another depiction in just a minute. But a continued zonal jet across both the central and northern part of the United States, and then halfway across the Atlantic. So this is a fairly zonal flow that we'll see from a hemispheric perspective in just a minute. But this is a really intense cyclone that I thought I wanted to draw some attention to. Here is a cross section through the jet that's coming off the coast at the same time, 12Z today. And you can see that 300 millibars is right about here. And so that's a polar jet core, but it's got subtropical components associated with it. They're not vertically superposed. So there's 3 separate jet cores, and it's a complicated structure. Not really an intense upper level front associated with the polar jet, but a really intense region of horizontal shear all the way up to 100 millibars and likely higher than that. So it's a very impressive jet. It's zonally oriented, and on its cyclonic shear side is now where that intense cyclone resides in the Greenland Sea. Here's a hemispheric perspective of the jet at 200 millibars. And I think, you know, I look at these things a lot, and my impression of this is that this is a remarkably zonal jet. It also has the basic characteristics of the Northern Hemisphere wintertime jet. That is, the subtropical jet component of it, in this case, quite weak over the southern Atlantic, hits northwestern Africa, then kind of comes around, and the jet curls up into the Scandinavian countries. That's very common. The fact that there's very little waviness on this jet anywhere, including the subtropical components of it, is somewhat unusual. I think that's but characteristic of a positive NAO situation where you especially get a roaring jet across the Atlantic basin, which is the case today. So anyway, kind of a non-wavy jet, and that is of interest to me because we've got this extraordinary cold pool sitting just to our north, and there's not any particular mechanism that will drive it southward over us. It's just going to kind of move to the east, it looks like, as it decays. So kind of an interesting large-scale setting today. I don't know which map I'm on now. I guess I'm on that one. And what was the next one I wanted to show? Nothing's happening when I go to that next tab. Okay, I'm not sure what's happening there. So I had something set up and now I forget what it was. So I'll go back to our current weather. Just this was an excursion motivated by what I saw going on in the satellite image over the Greenland Sea. So now let's take a look at, I'm having some trouble here, Pete, all of a sudden. What's going on? I set a whole bunch of things up and they're not seeming to work. Okay, I wanted to just show you the surface map as portrayed by Alicia Bentley's maps over the continental US, valid right about now, 18Z-ish. And so we've got a really intense Arctic high sitting just to our north, centered, I should say, just to our north. And that is part of the reason we've had this persistent cold. And the black lines here are sea level isobars, and the thickness lines every 60 decameters, every 6 decameters are in blue until you go above 540, then they're in red. So this is a sub 4, what was it? What did I find it? Sub 480 decameter thickness over Lake Winnipeg. This is just about the coldest air I've ever seen in North America. I don't remember 480 or below decameter thicknesses is really rare. Maybe I've seen 476 before, but that's about as low as it gets. And we'll see this reflected in the actual temperatures at 850 in just a minute. But a sprawling anticyclone over all of central and western Canada, and then it's nosing down. It looks like the cover of Seymour Hess's great book from the 50s, where there's a big anticyclone nosing down along the Yucatan Peninsula. This is really a gorgeous example of mid last vestiges of cold air outbreak in the continental U.S. I don't think we'll be able to mount one like this again. We're already in the middle of February. This is probably it. And look at the extraordinary sea level pressure gradient when you reduce things to sea level that really identifies where the high terrain is. So it's a beautiful example of that. You even see a little bit of that with the Appalachians, frankly. And a straight, the shading is 250 millibar wind speed. So a straight zonal jet with a little bit of a perturbation here off the West Coast. Otherwise, pretty much zonal across the country. Relatively rare that we are so cold with westerly flow aloft. I mean, one of the things that I've noticed living here is that when the flow turns westerly over the high terrain to our west, that usually means we are about to see the temperatures head back towards Climo, no matter what time of year you're at. And sometimes even warmer than Climo, like in the late summer, early fall, and sometimes the early spring. So this is somewhat unusual that we're, I think, correctly anticipating a pretty frigid weekend, I should say, much like last weekend. And yet we have zonal flow at Mountain High West. Yes, Michael.
Yeah, when we get to the forecast portion, I'll show one of the factors in that might be the extreme stability of this cold air and the depth of the cold air that's over us, that's preventing that westerly flow from really having much of an impact.
That's a good point. And in fact, the famous 2-minute temperature rise, I'm putting the cursor at Spearfish, South Dakota, in January of 1943 was probably a function of a similar setup, just entrenched cold air. And then it begins to get eroded, maybe perhaps by the synoptic flow, and then flow in that case over the Black Hills, pushed it away a little bit from the ground. The temperature rose 52 degrees in 2 minutes. And then some minutes later, the cold air sloshed back because you couldn't sustain the sort of hydraulic push over the high terrain. So that's a very good point. This air is really strongly stratified. And so it's resistant to being moved to a large degree. So that's the large scale setup. I wanted to point out just how cold is it underneath these extraordinary thicknesses. So here's a surface map for 12Z, so it's roughly the same time. And we were looking at Lake Winnipeg is where the lowest thicknesses were. And look at some of these temperatures, minus 31, minus 20, minus 42. Is it Fahrenheit or Celsius? Actually, it doesn't matter. It's the same. So incredibly cold air is just to our, and look at the gradient, it's quite large too. You get into western Saskatchewan and you're talking about temperatures only -9. So it's a huge gradient of temperature, extremely cold, just to our north and west. And now since we're here, we can see we're 0 still at 12Z this morning, not surprising, -9 at Minneapolis. Below 0 temperatures in a lot of places, light snow and 14 in St. Louis. This is something they're not used to. And I think even down south, you had some really cold temperatures. Jackson was 33 over 30. So there's a chance that a snow flurry comes out of that. I think it's more likely they have freezing rain there during the day today, as we'll see on the radar. But really miserable weather for a lot of these places that don't expect temperatures to be ever in the 30s with precipitation falling. So pretty ugly. And even cold on the northeast coast of the United States, temperatures in the teens, and that'll get worse for them as the weekend rides through. I'm quite sure of that. We had a beautiful lake parallel snow band in Lake Michigan today. And I don't have that included in things I'm going to show today, but it was entirely along the entire long axis of the lake. And now some of that snow, or maybe unrelated to that band, but some other lake effect snow is affecting parts of the lower peninsula. Anchor is up near Marquette, and he had like 18 inches of snow one day, 12 the day before, but not so much today. So maybe he's not getting that much snow today. I don't know. And then if we go out to the West Coast, 30 degrees even in Seattle. So that's a cold day for Seattle, and much colder in Eastern Washington. So this is in cold air building over British Columbia. That's the kind of setup that can sometimes put the threat of snow in the Seattle forecast, because if you get cold air coming down either the Fraser River Valley and then the Puget Sound, you can get just what you need, low level cold air and a precipitation event on top of it, and you can get a pretty decent snow. I remember mid-February, we got a couple of good ones while I was there. So that's something that might be of concern. And then you can see where the Rocky Mountains are. It's very cold in the plains of Colorado, considerably warmer to the west. So let's now, what was I going to show you next? Oh yeah, I mentioned already that we're in the midst of this cold spell. If we can get through Monday, and it looks like we will, with a high temperature at or below 11, it'll certainly be at or below 10, it looks like, then we will have had 10 straight days at that temperature for a daily high temperature. And that hasn't happened here since 1999. If it had been only 10 degrees on Wednesday, we would have been about to shatter, or tie, I should say, a 60-year-old record, last set in late January 1963, of 10 straight days with a high temperature 10 degrees or colder. Both of the times that we've had 10 straight days of 11 degrees or colder were the last 2 weeks of January, which climatologically is much more expected than now. So this is standing out as a pretty unusual February so far. In fact, it's 14.5 degrees below normal through the first 11 days of February, according to the Weather Service tabulation for Madison. We had an inch and a half of snow last night. We've got like 5.5 for the month, and we're above average for the season in terms of the cold as well. So there's a bunch of interesting things going on this month of February. You'll see, I think when we get to the forecast, we don't expect that we're going to even climb to Climo in the following week. So we're going to get to probably the 18th-ish, 19th-ish of February, nearly the whole month, well below average. So it could go down as one of the coldest months in terms of being below average that we've had in quite a long time. I can't remember a double-digit below average month off the top of my head.
John?
Yes.
I was going to also note that it's interesting that on the 28th or 29th of January, the Climate Prediction Center issued their forecast for sort of temperature probabilities for the month of February. And they had much of the, I think, eastern 2/3, certainly eastern half of the United States, being likely above normal.
Oh, is that right? Wow.
So this is going to be an interesting end of the month to see what actually, how this all winds up. Maybe we get into a really warm pattern that makes it all work out for verification. But
yeah,
it's going to be hard to do that.
It's going to be really hard to do that with about 14 inches of snow on the ground here, and some of it just brand new, pristine. It's just not going to be easy to get rid of that snow, because that's job number one if you want to warm up. Until that happens, it's not going to get warm. So yeah, what an interesting, I didn't know that. I forgot all about that.
Can I interrupt for a minute?
Yeah.
If you remember a month or so ago when they were making these forecasts, that we had just had the sudden stratospheric warming, which usually means that winter's going to not come back. And what's happened is very bizarre. I've been showing you over the week what's happened with this polar vortex that's trying to reform after the sudden stratospheric warming. But the polar vortex now is sitting to the south of the pole over Europe, sort of, or over the North Atlantic, such that in North America, we're in a straight northerly flow, straight from the pole into southern Canada, from the polar vortex, which is not sitting on the pole like it should be. And in fact, the air over the pole is not particularly cold like it should be, because it's a polar night in the stratosphere. It's not particularly cold, but it's extremely warm over Asia, which is very strange. So something has happened with the global circulation, which I'm not an expert on this. I haven't watched it for dozens of years, but in the last 5 or maybe 10 years that I've been watching it, I've never seen anything close to what's going on right now. It's the most strange stratospheric pattern that I've ever seen. And it's now connecting with the westerlies and the polar jet over the eastern United States at some lower velocities than it normally would. So I think this whole thing is actually driving the cold air south and mobilizing it over North America for reasons that I would never have anticipated and I don't fully understand. But it's all connected right now. And maybe at some other time I could put together a talk and show all of what's been going on. But it's not, this is not what you would find in a textbook, what's going on right now.
Yeah.
And I don't, it's totally, I think it's unprecedented.
Well, I've got a couple of slivers of evidence that talk to the idea of something being unprecedented. I'll show you that in just a minute. Greg, I think it would be wonderful if when this winter is over, one of our Friday discussions was just dedicated to discussing aspects of this winter, and not just regionally, perhaps also hemispherically, because that would be a really good way to spend one of our weather watches. We'll have a boring March or April Friday, and we should just throw that together and do it, because I think there's a lot of potential research questions that are lying out there, related to stratospheric and tropospheric interaction and what the vortex does and all these other things that you've been talking about. I think it would be really fun to do that. I would be game. So we should put our heads together on that.
I think we should.
Yeah. Thanks for the comment. I want to just go now to the upper level charts and show you a couple other things. I'll be done in just a few minutes. Here's our 500 millibar map for this morning at 12Z. And this is one of the weirdest looking 500 millibar maps I think I've ever seen. Straight zonal flow. Don't forget, we're on a weird projection. This is just about perfectly zonal from Wyoming all the way to England at that latitude. And here's very cold air at 500 millibars, minus 46 in Western Ontario, minus 44 at International Falls, minus 43 to the northwest of Lake Winnipeg. So a minus 45 plot of air at 500 millibars. I've never seen a minus 50 contour at 500 millibars over continental North America. So we got close, but I didn't quite see it. 500 millibar map. So yeah, kind of an unusual one. It's really cold over Lake Winnipeg. That's not surprising, but the zonal nature of the flow is quite interesting to me. And then we've got this also a pretty decent region of geostrophic cold advection and strong cyclonic shear. So there's an upper front that's probably putting a little dent in the tropopause right above us. Whether or not that ever evolves into anything substantial is another question. But there's a chance for that to happen, but it'll be well downstream, probably in the North Atlantic again. But that might reinforce this tendency for cyclonic activity to have really sprouted and become intense over that part of the globe. And that spells usually the end for cold snaps for us. So that's kind of interesting. But anyway, I wanted to go to another level, and that is 850. And so here we are over our region. So right around Lake Winnipeg, minus 37.1 the analysis has, and it's minus 35 on the northwest side of the lake complex as a measurement. So that's really cold air at 850 millibars. I don't think I've seen it much colder, if ever, than that. Maybe January 2019 was a little bit colder than that, but this is a really intense cold event. And again, you can see how it's flooding the plains, and now there's a decent cold front coming down, heading toward Josh down in Texas, actually, with some temperatures that are going to be getting colder as the weekend goes on. And then finally, I'll go to, well, maybe not finally, but I'll go to 300 first, see what I say about that. So you can really see that the zonal nature of the jet all the way from the Dakotas almost to the British Isles, and with a little bit of a ridginess with an upstream trough off the Pacific Northwest coast. But there is not much waviness in this flow at all. And that's true even if you go up to, let's go to 200, where one might imagine you're more firmly entrenched with the subtropical part of the jet. Even there, you see mostly this strong polar jet. And then on the southern periphery, intrusions of a weaker subtropical jet. It's not really the dominant feature over North America and adjacent waters at the current time. So that's quite interesting. I wanted to show you something about the nature of this cold event over us versus the cold event that occurred a couple of Januaries ago. So let me just show you this PowerPoint slide. I'm going to go back to the beginning of this. I don't have them in the right order. This is the standardized anomalies of temperature at 850 millibars. And I'm only showing standardized anomalies smaller than -2 sigma. And this is from the beginning, 0Z on the 11th of February of the current event, and with the one that'll get us this weekend. And I'll just step forward at 12-hour intervals. Look at how sprawling this thing is. No, how come I'm not able to do that? Okay, here we go. Look at how sprawling this anomaly is as we move forward. So it takes up a huge part of the real estate of the central part of North America as we're going from all of these different times. Now, contrast that with, I don't know what the hell's going on here. I'll have to get back to this thing. And now I want to show you one last thing, if there's going to be time and no interruption. But
John, quick thing. Sorry to interrupt
Yeah.
So what's really interesting about those two events, or the contrast between two events, is the local nature of it. I'm wondering, does that have something to do? I'll show a cross section across the country about the stratification differences. One might have been very localized, and so a westerly flow just quickly erodes it, but it wasn't particularly deep. So a very shallow layer of cold air that was easily eroded, as opposed to the circumstance we have now.
Maybe, except that the other idea I have in my mind, and it's one of the things that shows up in these really nice new papers that are out, is that underneath the TPV, you get a cone of cold air.
Right.
And these things can be of small scale, the TPV. And so the cold air anomaly can be of small scale. So if you get hit directly by one, it's bitterly cold. But they're not going to be the kind that do damage to the citrus crops down in the south, because they just don't have that kind of aerial extent. So Zach Handlos and I are thinking about trying to put together a proposal, NSF, to actually look at these different types of cold air outbreaks and trying to understand more about what are the differences in their large synoptic scale evolutions, because there's something distinct about them. The small scale TPV based ones and the ones that are from a large wave scale evolution, like the one we have right now, is quite different. And therefore the human impacts are substantially different between those two classes of events, it seems to me. But I don't know if it's not stability. I have a feeling that's probably not the primary answer, but it may well be a factor in some of these, about keeping them local. I'm not sure.
Right. I think you're right about the aerial extent of it, but I think that may also be related to stratification issues as well. But it's an interesting question.
It could be. The last thing I want to show you is the current cold pool situation. Remember, last week, I think I did show you the dip through the first few days of February. But look what happened here. And this was inspired by Michael's suggestion on the run-up, the September through December stuff, to put the maximum and minimum on in blue. And I did that. We had the all-time warmest February 7th and February 8th over the Northern Hemisphere back to 1948. So, Greg, this is kind of exactly in line with the anomalous nature of the winter that you were talking about in other terms and perhaps more broadly. But at least in this one measure, it shows up as the all-time warmest day ever, February 7th or 8th, by the aerial extent of the cold pool. And then a quick recovery, but we're still well below average. And we're running 8th warmest through February 11th since 1948. So that's out of 72 years. That puts us nearly in the top 10% of warmest years. And if we can somehow manage to have a flood of warm air in the high latitudes, we might crack the top 5 by the time this month is over. So this has been a very unusual winter, and topped off with the only record-setting day I've ever seen, actually, in the last few years for an all-time warmest day on a calendar day. So that's all I have. Oh, I wanted to show you one last thing.
So wait a minute, before you go on, what you're saying is that 850 was the warmest ever?
No, I'm saying that the aerial extent of the -5 air on the 7th and 8th of February was the smallest it's ever been in the historical record. Yeah, this year. This just is last week. Yep.
Yeah, so that's consistent with this polar vortex, because
exactly,
except for over us, it's been extremely warm around the rest of the globe.
Yeah, that's right. And so there you go, and it shows up in this record. Isn't that wild?
Yeah.
And then here is a map from last night. What happened? Okay, this is 12Z on the 11th. Somehow I got back to a time I didn't want to show, but anyway, this is reasonable time. This is the -5 isotherm is the magenta line around the hemisphere. The average position of it for the time 11th February 12Z is in green, and then plus and minus a half a standard deviations in white, and then +1, +2, +3, and -1, -2, -3. So you can see, as Greg says, we're the only place in the whole hemisphere that's really much colder than normal. Maybe the British Isles and parts of Europe the same, but a large part of Asia is much warmer than normal. And then it's true also over the Aleutians, we're much warmer than normal heading into the +2 standard deviation region there. So but it points out to me that the difference between the magenta line and the dashed green line is the difference between the average and the current value. And it looks at a glance to be almost like a wash. Some places are a little colder than they should be. Some places are warmer, but overall it's quite a bit warmer than average. So that's a very misleading way, I think, or the potential to be misled by looking at this diagram is high. But the calculations come out and tell you that we're well above normal. Even now, as we're recovering some cold air at 850 millibars, we're still well above normal in terms of the temperature, which means well below normal in terms of the areal extent. So it's been a weird winter, and we may, as I said, make a run at the top 5 warmest. That would mean smallest areal extents averaged for the season that we've ever seen since 1948. So I'm hoping we can get there. So that's all I have. I'll stop sharing.
Okay, John. Okay, thanks. Thank you, John. And I will get connected with sharing. Host disabled participant screen sharing. Pete.
Oh,
Yeah, I gotta get you back on there.
Still disabled. Okay, here we go. Okay. Good morning. Thank you, John, and thank you, Pete, for recovering from that unfortunate interruption, and we'll do our best, the department will, in trying to prevent such things from happening in the future. So what I want to do is first just start off with a comment I made earlier about the temperature over North America, the forecasted temperature. What I'm showing right now is the Climate Prediction Center's, NOAA's Climate Prediction Center's forecast for the month of February that came out on the 28th of January, which called for above normal temperatures again for much of the eastern 2/3 of the United States, even from the southwestern United States across the Midwest and Northeast and Southeast, with it being warmer than normal. The greatest likelihood of it being warmer than normal being over the southern parts of the Gulf states, from Texas to through Florida and then into the southeastern United States. And we know, I haven't looked at the actual verification, obviously we haven't finished the month yet, but it's going to be it's going to be a challenge for us to actually get to meet this forecast, for this forecast to verify. So that's really an interesting feature. Next, this was just, again, based on some of the things that John was talking about. I did a very quick cross-section across the United States from Oregon to southern New Hampshire. And this shows potential temperature, or the green contours, and the potential vorticity is the color fill pattern. The purple contours are the winds. And what I wanted to point out, which I think is really interesting, is you can see the measure of stratification is, measure of how, one measure of stratification is the spacing of the isotopes in this particular diagram. So these green lines being relatively close to spaced relatively close together indicates a high stability over pretty decent portion of the United States, from the Rocky Mountains, which you see in sort of the silhouette, all the way out to the east coast of the United States. And so with this strong cold air in place, even with a westerly flow, you imagine, it's not even really descending and warming adiabatically. There's maybe a little bit, you can see at the bottom of this, but there's this cold dome that's over the eastern, 2/3 of the United States, and it's going to be very hard to mix that out until you get something else to change it. And that means weather systems that are passing by along the dynamical tropopause, which is oddly flat through this cross section, are going to basically have very little influence on surface development beneath this area of the stratified layer. So from 600 millibars down to the surface, you're not going to have much influence in this region from weather disturbances in the upper troposphere. And in fact, they're very little, at least across this cross section, which I think is kind of an unusual one as well, just in terms of the way the flow is set up.
Yeah, that's really interesting, Michael. It looks like one of those aqua planet simulations or something,
Right.
At the initial time, there's nothing going on, but any disturbance would only grow from 600 millibars to the tropopause, because that's the only place where it's possible to move the air in the vertical.
Yeah. So it's going to take, a really potent disturbance or some other process to really get things moving through that. So the next picture is just sort of the U.S. hazards page. Again, this comes out from the Climate Prediction Center, and this is looking at the period. Look at the period for 3 to 7 days, and it's a mess. We'll take some things off here. First of all, in terms of precipitation, it's expected to be rather wet along the east coast of the United States, with the possibility, in fact, of heavy snow in regions of the southern plains all the way into the northeast. These are regions that are expecting the possibility of heavy snow. Heavy precipitation also expected, again, from the sort of the Tennessee Valley, or actually from the Gulf of Mexico all the way through to the the mid-Atlantic states, and then the southeast as well being relatively wet. How's soil moisture in terms of how things are? Well, it's already kind of close to normal. It's not particularly wet, so they can certainly use that, I guess, for the upcoming spring season. But you can see a good portion of the western United States, from the high plains down into the southern plains, are going to be are experiencing a severe drought, and that's something that hopefully will get mitigated. You can see a little carve out in just to the southwest of Reno, Nevada, and in the forgetting, not the near Lake Tahoe region, and that the Cascade, not the Cascades,
Sierra Nevada.
Sierra Nevadas, thank you, where they got that significant snow just a few weeks ago, and so they're doing okay there. And that mountain snow melt hopefully over time will sort of quench the thirst of that region. And then finally, for temperatures, you can see significant, much below normal hazards for the next 3 to 7 days remaining over the central part of the United States. The eastern part of the United States, doesn't get super cold, but really the central part of the United States is going to be experiencing that cold weather. If we go back to the period, this is now for the period of the week 2 hazards. This was again made on February 11th. And this is the 8 to 14 day map. Again, looking at the temperature here, you can see, again, much below normal temperatures in this region. And in terms of hazards, the possibility of snow as a hazard, although John will look at that as like a nice gift. Yes. And in terms of winds, some kind of windy conditions perhaps on the 8 to 14 day range. So cold continuing at least into that period. So moving on toward our local weather and what's going to happen over the weekend. Here's a meteorogram, which shows again that descent in temperatures. A week ago, we were talking about temperatures getting rather chilly with that minimum and geopotential that John indicated at 500 hectopascal. That's pretty significant. And we saw the model forecast last week. We're actually tending to bring that southward over Wisconsin and Minnesota. That looks like it's actually going to stay to our north. We'll see that, or mostly to our north over the next several days. But when you look at this figure, you can see, again, our temperatures, basically the general trend is going to be getting colder over the weekend, Friday, Saturday, Sunday. Dew points aren't really going to be relevant in that, but also the possibility for a period of some precipitation. This case, it'll very likely be snow, starting sometime during the day tomorrow. And such snowfalls that occur during the day are called Martin events, because Professor Jonathan Martin likes to see snowfall during the daylight hours as opposed to having it occur during the night when everyone's sleeping. Kind of miss that.
Who doesn't?
Yeah, well, I can name at least one person, John, that doesn't like that. But he will remain nameless. Okay, how about how much precipitation are we expecting? And we'll look at the dynamics of the situation and what the trigger is, but I wanted to first just give you kind of a broad 30,000 foot view, if you will, of the forecast. Here's the SHREF, this short range ensemble forecast system that NOAA maintains. And you can see it's, in the mean of this ensemble, it's a little bit higher than I would have expected, but about, 3.8 inches or so during this time period. With the snow beginning, and many of the ensemble members, there's a big spread in the beginning time, but anywhere from just after midnight to just after 12Z with the snow beginning and lasting into the early afternoon tomorrow. So that's the forecast for snowfall. There are a couple of odd outliers, which we'll just ignore, maybe at our peril, but I think, a couple inches probably isn't, and I think that's what the official forecast by the Weather Service is not to be discounted. We've already seen that cross section. So let's look at the NAM and what's the culprit for this in terms of the producer of our precipitation. So again, this is a very odd looking map with the minimum and geopotential at 500 hectopascals right up, just to our northwest over southern Canada. Our broad westerly flow that, as John was saying, typically you'd expect that to just within a few days of this westerly flow setting up, we should be warming up. But all this flow is really just going right across the top of the mountains. It doesn't really mix down to the surface and create a nice warm thermal trough. So it's going to stay cold over us. And the key player in our forecast is actually in southwestern British Columbia this morning, just moving onshore in that region, getting to the radiosonde network. It's probably been well sampled by satellite observations and the winds that are derived from those satellite observations that's done downstairs in SIMS and SSEC. But this is going to be the feature, this vorticity maxima, that's the shaded pattern here is the vorticity, is going to be, I think, the main culprit to give us, to lead to our snowfall. As we step forward in the forecast, this is the NAM forecast initialized from 12Z this morning. You can see this element of vorticity as it moves into sort of a somewhat difluent flow. It was linear in shape initially, and it's getting a little bit more structure to it. You can see the geopotential minima kind of beginning to show up there, but you're beginning to see some regions of downstream of this vorticity maxima, advection of vorticity. And this is going through early tomorrow morning. It's approaching from the west. You can see this region where we have this difluent flow, but also the propensity for this to open up and you're actually getting downstream of the vorticity maxima. It's not a nice slug of it, but there is some advection downstream of it, which is going to be favorable for ascent as this particular feature moves by. Let me continue stepping back. And so this is arriving. Again, I would think that the snowfall would be starting later than we saw some snowfall maybe starting after midnight tonight. I think it's going to be much closer to dawn tomorrow. It's going to be the earliest that we would see that, just because that feature is still approaching us. And my apologies on the timing here. So this is noon tomorrow. You can see where the feature is. As you go through noon tomorrow, and then it's right on top of us around 21Z, and then to our east, after 21Z. And the westerly flow continues, and the heights begin to recover a little bit over us at this point as this feature continues to move along. At the surface, let me go to the surface map. Okay, so the surface map kind of tells the tale. Here's the cold air that's well in place over us. There's a little bit of light snow to our south this afternoon and this evening. But here's the snow arriving in the NAM by 9Z tomorrow. And it continues over us during the morning and early to the early afternoon. And by 18Z tomorrow, it's just about over. As we step forward, that's 0Z. You can see the snow ending during the afternoon tomorrow. And then the cold air is in. We have cold advection at the surface, low thickness advection, negative thickness advection. So the average temperature of a column continuing to stay relatively chilly. And as we step forward in time beyond this time period, as we go into Sunday, just cold with significant snow down to our south over parts of the southern plains, Oklahoma and northern Texas, actually getting some snow during this time period. So, but we are going to be at best cloudy as we go into Sunday night into Monday, but not, the likelihood of snow here. It looks like the four models are keeping it just to our south.
Should we expect the coldest?
I'm sorry, John.
Oh no, this is Benji. I'm sorry.
Oh, Benji, hi.
I was just gonna ask, should we expect the coldest temperatures to come Sunday morning then across the region?
Sunday morning, yeah, let's go back to that time. Great question. I mean, what you're going to want to get those really cold temperatures are going to be light winds. We'll have just a refresh of our snow cover, but probably not a significant addition to it. It's already pretty deep to begin with. So light winds, clear skies, and I think the clear skies will very likely have, but I think the winds we're going to still have a bit of a breeze on Sunday morning. You can see the gradient here, pretty decent gradient if we put the wind barbs on. And actually, let's zoom in a little bit, and we can look at the temperature forecast, and also look at we can bring up the MOS numbers for this. Let me just go here. I think I already have that map set up, but I'll go here, go to temperature. So you can see we have winds. I mean, they're not super strong. They're about 5 to maybe 10 knots. If I just bring the temperatures up here, this is this is Friday morning. Let's go to Sunday morning, 12Z. As it's moving, -6 so it doesn't get super cold. So it's not going to be, at least at this point, it doesn't look like it's going to be as cold as it was last Sunday morning, which we got down to -13 or so here in Madison, -13 to -15 in Madison. The winds, again, yeah, this is actually the winds at 12Z on Sunday morning are going to be about 10 knots or so from the northwest. So probably, this is probably the coldest night of the weekend, I think, because the clouds are going to begin to encroach again Sunday night into Monday, and that'll probably keep temperatures up by just a little bit. So this is 6Z Monday morning. We're only, I say only at -4, so -4, -3. So I think Sunday night will probably be the coldest of the nights that we're going to have, because it'll be probably Sunday morning rather will be the coldest period. In terms of snowfall amounts, I'll look at the 24-hour snowfall accumulation, and we'll just pick the time of Sunday morning. So this will cover the entire period here, and I want snowfall, not just precipitation. Okay. And it looks like the ECWF is now in. And you can see for amounts through Sunday, 0.8, I mean, about an inch or so. So it's interesting that the short range ensemble had a slightly higher amount, and maybe there's an issue with that, but about an inch or so is probably what's expected during this time period.
Look at that lake band. That is really great.
And that shows up in lots of thanks for pointing that out, John. Right, that lake band is in all the simulations. It's kind of mid-lake. I don't know if Greg or Angela or others might want to perhaps speak to that, the formation of these mid-lake bands. This is not something I typically look at, or John wants to talk about that.
Yeah, I don't know anything about them either, except that it's a waste of snow. Look at that. You're talking about 6 or 8. Nobody cares.
I think it's falling where it should fall.
Yeah.
And
no.
Appropriate.
Hey, yeah, I would comment on that. I haven't looked at snow bands on a regular basis to know that if there's any tendency in the models to create those of such a length. I mean, I guess I haven't looked at the model tendency as much. Do you see that frequently? And does it come to fruition? I mean, without going into the formation processes, is that a model feature?
That's real. That's real.
Okay.
And it happens when you get winds on cold days, when winds are parallel to the long axis of the lake.
Yep.
The land breeze forms and creates mesoscale convergence down the middle, which deepens the clouds to about 4 kilometers, which is much deeper than a regular lake effect storm. So where those bands intersect the shoreline, like in Gary, Indiana there, they're going to get heavy snow, maybe several feet. This is what also causes all the big snows in Buffalo for the same reason.
Right. Yeah. Okay.
How frozen is Lake Michigan right now? Is it mostly water covered?
I don't know. It must be open, because why would the model do that?
Right.
I think that at least before this cold snap, the lakes had a historically small amount of ice on them. So I don't know about individual lakes, but I bet that they're probably well below their average for a mid-February. That's probably right.
Another interesting thing to look at on these snowfalls is to look at Dallas. Look at Dallas for the middle of the week.
All right, we'll go down there and take a look.
Dallas just had a big, Fort Worth, just north of Fort Worth, there was like 100+ car pileup, and 6 or 7 people died because of the freezing rain that occurred there. And
look at the accumulated snow by like Wednesday.
Okay, let me go to that. This is nuts.
Just to follow up on the last lake question, I put some links in the chat. Michigan's about 20% covered, a little over 20%. So this is still wide open.
Yeah. Wow.
So yeah, this is the total accumulated snowfall. We can see where this begins. This is through Tuesday, Monday night. A few inches, 7-8 inches in the Dallas-Fort Worth area. And then as you step forward in time, you can see this about to just get a little bit more. I'm trying to bring this up. I think there's more coming. Oops. No, so that's the event right there, I guess.
Yeah.
Look at that.
With a little bit more on Wednesday.
That's pretty unusual for down there.
Yeah, that's a lot of snow. That's right.
Yeah. I think earlier forecast had it focused more across parts of Oklahoma. Now that's shifted a little bit to the east. But that's pretty extensive snowfall. Yeah, this is ECWF. Again, somewhere around just under a foot. The the Canadian model, the GDPS, is about 8 inches or so. GFS, just a little over a foot. And then the version 3 of the version 16 of the GFS, the parallel version they're running, looks like it's producing from last night's run. They shift that band a little bit further to the north over parts of Oklahoma. So it's going to be an icy period for the Southern Plains.
Is that 23 inches in the Red River Valley? Oh.
That's pretty amazing. That's going to make Ted Cruz rethink his vote tomorrow.
I don't know what's going to make individuals rethink that vote, but the Senate certainly has to change. I'll leave it at that. Okay. Well, I think I had one last thing to look at, and this is hope. All right. This is looking at the 768-hour forecast. So this is basically a month out. This is snow depth. I know John will be disappointed, but it looks like we'll finally lose. If this forecast were to verify, we'll lose our snow cover. Where are we right now?
Oh, man. Look at
we're
that.
in the blues, right? I mean, it's just, fairly extensive snow cover. This is not really representative because they only have 4 inches here, which is clearly wrong. But you can see it grows a while. That's the Southern Plains snow cover. This is through snow depth. This is through basically next weekend. And I'll just quickly click through this because I don't want to go long. We begin to lose some of that snow cover, and it just slowly begins to erode. How warm are we going to get if this were to actually verify? This is this is from 0Z last night, the CFS forecast. Again, this is totally a fiction, but at least gives you a sense of, that the seasons are changing. Will actually be, we could have a 0Z temperature, a temperature at 6 p.m. of 40 degrees. Can you believe it?
40 degrees and fog with drippy melting snow. Wonderful.
You don't have to make it look all that bad, John. Come on. And the temperature anomalies, this is another nice thing to look at. I mean, we're going to be above normal and actually be above normal for quite a while. If I just go back in time, again, if this were to verify, right? A warm period. And again, if you want to just click back, you can do that. Look at prior forecast for the same period. Warmth is on the way. How quickly we're going to get into that is a different story, but we're going to warm up. So the forecast, again, just to wrap things up, snow developing by dawn tomorrow, maybe an inch or so over our area, and then it should be over by, it'll be a light snow during the day, again, a Martin event that will end sometime mid-afternoon, and then we'll get cold as we clear out on Sunday night, and then remaining cold for much of the week ahead. With snow chances, maximized just to our south, maybe in Illinois, central and northern Illinois, but it looks like for us, we'll stay out of the any significant snow for the week ahead. Yeah, anyway, that's it. Thank you very much. I appreciate your patience with the disruption we had. We'll work to prevent that from happening for future broadcasts, but people always find a way to be disruptive, but we're going to do our best to stamp that out. So thanks again, John. Thanks, Pete. Thanks everyone for the comments. Angela, Greg, Ben, this has been great, and we'll see you next week.
Yeah, thank you, Michael. And let's watch out for that Thursday night, Friday event. If the models are a little bit wrong, it's a sort of southwest to northeast oriented trough. If they're kind of wrong in the position, we could be in the snow instead of Illinois. So watch out.
Yeah, actually, let me just go back to 144 hours. You brought it up. I have to look at it. Oh gosh. That's the ECWF forecast, which I think is much different than the earlier ones. It actually does bring that snow in. So
there you go. It's not a perfect track, but it's better than the one on the GFS from 0Z.
Yeah, look at the GFS from 12Z. So these are two model runs again the same time. Always fun to look at the model comparison. I know people are probably leaving, but I'll just look at that. So let's go back to the right time. All right. Wait a second. Do you have the right time, John?
I like 0Z on Friday, maybe.
0Z on Friday, which would be. Oh, sorry, wrong forecast. There we go. And we went 0Z on Friday. It's 168 hours, just under 168 hours.
Holy mackerel.
I may have been looking at the wrong map, John. My apologies.
Okay. I haven't seen the newest one. I just noted this morning looking at the weather discussion for my class that we got to keep our eyes open for Thursday night, Friday. It's not out of the realm of the possible. But it's not in the forecast right now. I would say that.
Yeah, that is right. That's right. Yeah, the GFS FV3 actually does bring it in. That's from last night's run of it. Or actually one that was initialized, not FV3, the version 16 has us in the snow on Friday at 0Z. The operational run of the GFS has it well to our southeast. Canadian model brings in a little bit to the northwest. ECWF is decidedly further east into Ohio. So it's not done yet. Again, this is an extended range forecast, medium range forecast. So you wouldn't want to just write it off and say no snow. Yeah. But it's unlikely, and we don't really need it. So
also, I'll hope for a new low temperature record in Minnesota this weekend. It was -46 2 nights ago, so 15 degrees past that, and you get a new all-time low temperature. So I think it'd be cool to see that.
That's
great to hear.
That's asking a lot. That's like saying, that's like approaching an asymptote. 15 degrees is a lot when you're down that cold already. I don't know.
Well, I can hope and pray, right?
Yeah, you can. There may be some temperatures just above the border into Saskatchewan or Ontario that get colder than they've ever been. That's possible, but I don't know if it's going to get to Minnesota. I hope it does for your sake.
All right, we'll see.
Are you in Minnesota right now?
No, I'm not, but I have family in Minnesota.
I see.